In the launch, you were introduced to some new notation that allowed one to more concisely express the precondition, the postcondition, and the loop invariant. But there were still other parts that were not captured by that notation. So now we are going to introduce some more. So here's an annotated algorithm for copying vector x into vector y, annotated with a precondition, a postcondition, and the loop invariant. We can use the notation hinted at in the launch to annotate this particular program. Y equals y hat indicates that when we start, y has its original contents in it. The k becomes 0, now is changed to x is partitioned into a top part and a bottom part, and the same for y. And then we can express our loop invariant by saying that y top y bottom is equal to x top y bottom hat, and that just means that the top part has been replaced by x top, but the bottom part has not yet been changed at all. So now let's focus on the loop itself. There are all kinds of parts here that we now need to still create some notation for. We highlight them here. The loop guard still needs to be somehow related to our new notation, as do the expressions just before and after command S. And notice that there it's important to be able to isolate the element indexed by k, because that's what we used to determine what the update to y actually had to be. So how do we do this? Well, first of all, we need to have some way of saying what the size of a vector is. And we use vectors as a special case of a matrix. A matrix has a row dimension and a column dimension. The number of rows we will indicate by m, the number of columns by n. So m of x, when x is a vector, is just the size of that vector. We also want to be able to expose the term in a quantifier that we carefully isolated. And we do that by saying that x top, x bottom is partitioned into x0 and then chi1, x2. What does that mean? That means that we relabel x top, x0, and x bottom has now been split into its first element chi1 and the rest of the elements x2. Or it might be that we want to split that element from the top part of x, in which case x top becomes x0 chi1 and x bottom becomes x2. So that's the repartitioning that happens at the top of the loop to be able to expose that term that was split off from the quantifier. Now at the bottom, we want to then be able to take that element and add it to the other part of the vector so that we can capture movement through the vectors. So on the left here, x top becomes x0 chi1. The element chi1 has been moved from the bottom part to the top part. And on the right, you see that x top, x bottom becomes x0, and then x bottom becomes chi1, x2. And that means that the element now has been moved from the top part of x to the bottom part of x. And finally, we need to be able to assign to the element indexed by k, but notice that now we have created labels for those elements, and therefore we can say psi1 becomes, where psi1 is the lowercase Greek letter that we associate with vector y. So what I want you to do now is to go and play around with this in the homework, where hopefully the notation is intuitive enough that you can figure it out.